Hey everyone, thanks for listening to another episode of DIB Innovators. Today I'm speaking with Justin Fiaschetti, CEO and co-founder at Inversion. Justin, thanks for chatting with me today.
Thanks for having me on. Excited to talk about what we're working on.
Your company is so cool, and what you're doing is going to be a blast. As we get it going, like I do with most guests, kind of tell us how you got from, I know you had some time at SpaceX and some other, but how did you kind of make that journey through your professional career just to see how do you get to start your own space company?
Yeah, no, absolutely. So Inversion is focused on building reentry vehicles to enable 1 hour delivery of cargo anywhere on Earth, right? So basically storing cargo in space and then having it be able to be called down to any point of need, whenever, wherever, land in any environment. And that concept, that idea for a business came about when my co-founder and I were living together back during the pandemic. And we were kind of just shooting the shit one day about, what comes next in the space industry? What will come after all of these rocket companies are built? And one of the things that we noticed was that space is super great at accessing the globe. Like you put up satellites and they orbit in low Earth orbit, and they're constantly moving around so that, they're always covering some part of the globe, and that changes. And if you put enough of them up there, you can cover either just a single geographic area continuously, or you could cover the whole world all at the same time. This goes back to the 60s in the Corona program, where they were looking to take pictures from space, and they would drop film canisters back down to Earth, to go and catch, so that they could spy on the Soviets. And so, when we were looking at this kind of concept of using space to access the globe, we realized that could be super useful, right? For point of need use cases where cargo can make the difference in a mission, especially around contested logistics or just highly remote areas. Fundamentally, you can't pre-position cargo across the whole globe in the oceans and in other nations, but you can pre-position the cargo about 400 kilometers above any point on Earth.
Yeah, I want to peel that in back, definitely, because there's a lot of cool things with that. But at the time, you've worked at Space on Raptor engines, you worked building engines at Relativity. Everyone that works for SpaceX I've interviewed, you got to tell me what it was like, just because it's such an iconic brand and Elon Musk. And the Raptor engine is a monster. So tell me a little bit about working there and kind of the engine, what you enjoyed with that, and what you learned that helped you build this company.
Yeah, totally. So I was down in McGregor, Texas at the test site. I was working on particularly the test stance for Raptor. One of the things that is like people talk about, but is still hard to appreciate until you've been in it, is just how fast everything moves within the company. Like for SpaceX, everybody there is an owner, right, of a piece of hardware or a process, and is highly empowered to go and do the thing, right? Go and build the product, go and redo the process, et cetera. And so that was one of the big things that kind of struck me was, we would get engine shipped in, and then within a couple hours have it mounted on the test stand. And I think now they've probably even accelerated that so that they're mounting the Raptor engines so fast that they can test them and get them off and do multiple engines a day or something like that. When you start to look at the scale at which Starship needs to operate at, or at least the scale that they've spoken about, with 33 engines on the base and 6 engines on the ship itself, just that throughput of engines is unbelievable. Imagine if every aircraft had, whatever that is, 39 engines. The GE Aviation and Rolls-Royce, they would be completely overwhelmed, completely swamped. And we wouldn't have the infrastructure to go and do that. And so rethinking how engine testing and how the processes of manufacturing and even just as simple as how do you mount the engine on the test stand? Those extra 10 minutes add up when you have to do so many engines.
So were you able to, was that an Elon Musk driven process, or that just kind of, as you there, it was just kind of one of those things?
Yeah, I think a lot of SpaceX, Elon sets kind of the high level culture and direction, and then he'll come in, from from time to time to make sure things are aligned well. And then, the leaders in the company are then empowered to execute on that vision and execute on that process. And then, therefore the engineers are then led. I didn't personally have any interactions with Elon at the time, but you could definitely feel the urgency that he would bring to the company.
Yeah, I think it's interesting. Everyone owned a process because a lot of times you find it. I'll be curious how you've implemented that, because if someone owns something, you're the boss, especially smaller company, time matters. If it's not the way you would have done it, but it still may have been effective, that's a challenging thing for, leadership to get over, even though I think in the long run it does. If you hold to a high quality, high standard, high output or outcomes, can be super effective, but it just may not have been the way, for example, you want to do it right now at Inversion. How do you look at that? How do you pull that in?
What I try to do is focus on the outcome of the process or the design or what have you. I see my job as CEO as setting the kind of long-term vision and direction that we want everybody running at in the near and medium term. Right. So the concept of commander's intent, right? Here's what we need to go and do. I trust you to go and accomplish your portions of it. And we try to empower people to make those real-time, day-to-day decisions in the way they see best to meet that end objective. That's super important because maybe at a 10-person company, I can make every decision. But I'm not the smartest or the most effective or the most knowledgeable in all areas of the business, right? That's why we'll go and hire just tremendous engineers, tremendous operations people, recruiters, marketing, business development. And so our job as leaders, myself and my co-founder, is to hire amazing people, give them a clear direction on where to go, and then trust them in their execution on that. And correct along the way if there's confusion or lack of clarity. And then at the end of the day, are we achieving our goals and are we achieving the outcomes that we want, regardless of the process? That's the 90% thing we try to make sure of. And then maybe there's 10% that will go in and look and say, could we have done a better process? Does this process complicate things in other parts of the business? But if you can just keep stacking those wins of we have met our objective, or we exceed our objective, things tend to work out, I've found.
That's empowering. I mean, that's obviously super important, I think, for companies to, especially as you get into scaling.
Totally.
When someone owns it, they need to be efficient because they don't have the time to not be efficient.
Totally.
The central blocking mechanism in the company.
Totally. We have 3 tenants within the business. I don't love company values. They're not super actionable. It's hard to kind of wrap your head around which design of a part is more empathetic. I don't know what that means. So we try to have actionable tenants. And the third one is we eat when we kill, which is, nobody's going to go do the work for us. Nobody is going to go call the vendor. Nobody's going to go drive, 5 hours north to go to the supplier to grab the part. You have to be the one to do it to get the job done. And you're also empowered to make those decisions that let you eat, right? If you need to, one of my favorite anecdotes from early in the company is we had an engineer, maybe an engineer 2, early-ish career. And he's like, Justin, a vendor's not taking me seriously. So I sent them an email with vice president of hardware engineering as my title. I hope that's okay. I'm like, totally, dude. You gotta do what you gotta do sometimes, we try to control that a little bit more, but in the early time, those kind of things can make the difference.
Yeah. Solving a problem. They didn't ask, you just did it.
Exactly. Yeah. Yeah.
Well, fantastic. So you decided to build this company. How did you go about that? It's tough to build companies, especially hardware companies, space companies. How did you approach this once you left, your last gig?
Yeah, well, I think the first answer is with an extreme amount of naivety is the first way. There's a great power in the confidence in that you could do something without knowing actually what it is you need to go and do, because at least it gets you started. In actuality, though, we kind of first came up with the idea, tried to pressure test it. Hey, has someone else done this? Are we thinking about this wrong? Is there something that would fundamentally block using space as a platform for transportation, just as, the sky is now used as a platform for transportation? And there was nothing coming back to us that was saying that it was particularly impossible or particularly bad. And in fact, most of it was coming back and saying, oh, hell yeah, I would love to get, airdrops from space, or like, this sounds like something out of Call of Duty. Like, I can't wait. Being able to call an airdrop in of cargo you need in under an hour, as low as 30 minutes, everybody can kind of intuitively understand why that's useful when you're, in a video game or in a movie. But if you think about it in the actual applications, you start to get to where, okay, well, that's within, for example, the golden hour for medical treatment, right? Well, now, if you have a downed airman, you can get them cargo and supplies to keep them sustained until you can get actual, full-scale medevac in, which sometimes can be days if you're in a particular conflict in, say a very island dense area. But so the company side, going back to kind of how we started the company, we realized if we're going to build a space company, build a hardware company, you need a pretty sizable amount of money, right? It wasn't something that us as 22-year-olds could sum up ourselves. And we were fortunate to get into Y Combinator. Y Combinator is kind of the country's leading business accelerator. Companies like OpenAI or DoorDash, Coinbase have all come out of that program, and countless others. And when we applied, we spoke about inversion as kind of that next step in space, which is everyone's putting stuff up. We want to bring stuff down. And luckily the partners there saw the vision and decided to take a bet on us. And that allowed us to kind of start to build out the business. It provided, a small amount of capital to get going. And that then kind of snowballed to where we were able to go and raise seed round from, VCs to the tune of about $10 million or so. And that right there was, to us, we were like, this is as many resources as we'll ever need. This is crazy. And we were able to use that to execute on our very first vehicle and build out the team and design and build a spacecraft from scratch in-house, which is 25 people, and go and fly it in under 3 years from funding. Still operational on orbit today. I actually got a picture down from the satellite yesterday. And, that success allowed us to, raise a Series A. And this kind of is all paired with engaging with customers around, hey, if you could reliably get something in an hour, what would you do? What would you take that you do today and do it that way? But how would your behavior change, right? What would you do differently that you couldn't do yesterday? And that's really where we've seen a lot of excitement.
Yeah, that's fantastic. I've heard a lot about the accelerators. I haven't been involved with them, for us, but
I like them. I think it depends is my answer. Like, it worked well for us because we were so young and we just had no idea what we were doing. And it really helped give us a solid base. Like, if you founded a company before, you could go one way or another. My general opinion is there are accelerators that are highly niche, right? Like, one of my friends, he's doing oceanographic monitoring buoys, and he did accelerator through Maine, and they had a fishery accelerator or something like that. And that's super cool. I think that works very well. The more general business accelerators that are we're gonna take equity in your company and we'll accelerate you, I think are mostly bullshit, except for Y Combinator. That's the only one that's actually credibly produced billion-dollar businesses. And I tend to think that founders are better off, kind of building on their own or going to YC rather than doing, a second or third tier type of accelerator.
Yeah, the network that I have, unbelievable. Your mentor capacity, your mentor toolbox, if you will, is pretty full, I imagine.
Totally. You get anything, any question we have, we can shoot off a single text and get, the expert in it.
Yeah, that is crazy. So, yeah, obviously the customer, because you probably thought of this, I think there's a need, but you didn't really have product market fit, if you will. You didn't really know, but you were able to, proof of concept. Who were you targeting for that? Was it mostly defense, or was it across the board? Anyone you could talk to, and how did those conversations go?
Yeah, well, initially, we cast a broad net, right? We were we think we know about the defense. We think it would make sense for defense, but what else would it make sense for? And we looked at a bunch of things. We looked at very early on, we looked at return from space stations, right? Coming back from the International Space Station or something like that. And it kind of, a lot of those commercial space markets, we realized were not really strong customer bases. They didn't have a lot of, real tangible, like, durable markets today. Now, they might in 5 or 10 years, I don't know, but 4 years ago or whatever, we were like, they're a little too floaty, right? And that kind of is where we ended up concentrating on defense.
And how did you get connections into defense kind of acquisition folks or the operators? Because can't just pick up a phone and call, most people can, your nearest 3-star that's like, yeah.
Totally. Well, in the early days, the first thing we did was engage a couple like consultants or whatever and apply to some SBIRs and like that kind of like early, just try to get your foot in the door with a phase 1 SBIR with SpaceWorks. And we were actually successful on our first application there, which was helpful, right? That at least got us, hey, we are on contract with the Air Force or the Space Force. It was a big deal for us. It was $50,000 contract, and we thought it was the biggest thing ever. And SpaceWorks and AFWorks were great at helping to, make those connections early on, right? Hey, you should probably talk to the folks at AFRL, or hey, you should probably talk to, Transcom or AMC or something like that. Interestingly, early on, we had a decent amount of success at just cold emailing folks. Like, we would type up, we'd have our briefing and we would type up our kind of company intro and like really try to understand, at least from open source, what that individual was focused on and what they would find useful. And just be like, hey, we have this thing. We think it's probably could help solve this problem for you. Are you open to like a quick 30-minute chat? And like, let's say we sent out 50 of those and maybe 20 of them came back or 25 came back as a response, and maybe 10 of them said, yeah, let's meet. And then 5 of them introed us to other people, and maybe 3 kind of progressed down the line.
That's pretty good numbers right there. That's good conversion.
It was surprisingly high. Like it might have been slightly higher than that even. We tried to be like super targeted, right? We weren't just sending this to like, someone is like no connection, right? It was specifically at like logistics folks or the innovation arms of different groups, like that kind of thing. And to their credit, I think they saw it and said, hey, this is at least worth 30 minutes of my time. Because what we're doing doesn't exist, right? The concept is brand new, and the value of an hour delivery, I think everyone understood, is clear. And I'm sure the first thing they were looking for is this complete bullshit, or does this have any amount of legs? But luckily, people, and we had some really, really supportive early champions, at least bought the concept and were able to kind of connect us in, intro us, and then, that kind of snowball effect happens.
Yeah, that's great. So if we look at your first platform, it's the Ray, right? That's the one that is still, talk to me about, I guess we'll start off with, how does this sit on top of a SpaceX rocket and then gets released just like normal cargo, a normal bus that would get kicked out?
Yeah. So for all of our vehicles, they operate as normal satellites. They get loaded onto a rocket, like a SpaceX rocket, inside the fairing, launched to orbit. They pop off the rocket and then hang out up there and have their own solar panels. They have the ability to communicate down to the ground, et cetera, et cetera. And then once on orbit, they are ready and waiting to come back down. And so Ray, our first kind of tech demo Pathfinder vehicle, the first one we built with just 25 people, very similar thing. Launched on SpaceX Transporter 12 mission in January, separated, communicate down to the ground, maneuver, etc.
That's awesome. So again, I also think this is fascinating. 25 people, less than 3 years, put the company together, you raise the funds, you create this, satellite, if you will, this platform, launch it and have it effective. Talk to me about, there's a lot of challenges to go to space and then orbit in space and do all the things in space, communicate, maneuver. How did you put together that group of folks? Where did you get those to be able to, really empower this vision?
Yeah, recruiting is like one of the hardest things early on because, we're no name, coming, super young, crazy concept. But it was also like the most important thing. I think we probably spent 70% of our time on that early, like just an obscene amount of time reaching out on LinkedIn, making phone calls, trying to get intro to friends. And we pulled talent from a lot of different places. It's from your SpaceX's and your relativity space and your Virgin Orbit and, kind of that new space type of thing. A little bit from like the old primes. I think we might have one or two people from there. We tend to find that the people we pull from those big primes are generally on the younger side, as they haven't spent a ton of time there. The people that generally thrive at the startup environment like Inversion generally would leave a prime after a few years when they don't feel like they're progressing as quickly as they would have wanted necessarily. But for those first 25, they were all individual disciplines of engineering. So, with a software company, you can go and hire 6 developers or, 5 software engineers. And like, they're not interchangeable necessarily, but like they can kind of all work on similar things. For us, though, we needed a parachute engineer, which is totally different than like an avionics engineer, which is totally different than a propulsion engineer. And so there was this kind of feeling of constant restart when we made this great hire. Now let's completely throw out everything we did and start again on this totally different discipline of engineering. We have to go talk to totally different people, screen for totally different things. But the one thing we always screened for was basically like, do we think this person could be a future founder? Like, could they start their own company? And like, if the answer was yes, we tend to have pretty solid luck with folks that, we determine that.
Yeah. So that's a tough one because that's not your discipline and you're still pretty young. It's not like you've seen all these disciplines at work. Did you pull on the Y Combinator kind of connections to help you figure this out?
Totally. Yeah. I mean, I don't know what like certain software engineers do. Like I'm a mechanical engineer. Like I couldn't tell you the first thing about, or at least at the time, I couldn't tell you the first thing about how avionics worked, right? Y Combinator was very helpful in the early stages of getting us connected to folks that we could, ask questions of, ask them how they scaled their companies, founders that started autonomous car companies or other space companies, where we could kind of be like, hey, how did you like figure out the very first couple hires of like, you need your propulsion engineer, your software engineer or whatever. And it was just a lot of networking, right? It was, everyone talks about the power of networking. And at least on the engineering side, people often, stray away from that as not a thing they need to do in their career. We kind of had to flip that and say, oh no, we really need to go do this. We need to find an advisor on parachutes, on regulatory, et cetera. And a lot of those kind of advisors or friends were nice enough to be able to screen candidates kind of towards the end of their interview process when we've already kind of qualified them as, yeah, they've worked on great projects. They think in a first principled way. They have the right attitude. Would you mind screening that this GNC engineer surely knows how to do the math? Because I don't know the math. So, I can't tell you.
Right. That's great. So you're a small company, limited funding. What are the advantages of trying to do something hard, solving hard problems with those constraints? If you had much bigger funding bucket, what might you have screwed up or not done as well because of that?
That's a great question because a lot of people always think like more money solves problems.
Yeah. Throw bodies at it.
Yeah, exactly. And like sometimes it does, but like you said, it comes with a ton of like problems and pitfalls. One of the things that's nice about, well, it's not nice in the moment, but I think it's advantageous for the company for when not having a lot of resources is you're forced to be like super focused. You can't get distracted because you don't have the resources to get distracted with 15 different projects. You have to be like, we are doing this one very specific thing. Like that's number one, which is if you have a lot of money, it's very easy to get distracted. Sure, why not throw some money at this potential project and this potential bet? So that's one. Number two is efficiency, right? If you have a lot of resources, there's no practical reason to need to go and be highly efficient other than the general concept of wanting efficiency. Yeah, you need an extra engineer or two. Sure, go hire them. Is way easier than really gritting our teeth and saying, how can we get more efficient? How can we get better? How can we get, tighter and leaner? And then the third one is it forces you to look like the concept of dying as a company in the eye at all times, where you are like if we don't figure this out in the next 6 months, the company ceases to exist, right? And so it kind of, on the company level, you feel this sense of imminent mortality that forces you to really question the assumptions you've made and really push hard on what customers actually want this and what customers actually exist. You don't have the luxury of sitting around for years and being like, this customer, I think, wants this. You need to go and like really validate that.
Yeah, that's a great point. Yeah, the sense of urgency that you could go out of business at any point. I was listening to NVIDIA's CEO, and he's like, I still have the mindset, trillions of dollars, cap. He's like, I still feel like every 90 days I might go out of business.
Yeah.
Yeah, but that mentality, now a huge company, that founding in that mentality definitely gives you a different perspective and changes how you operate, to be honest. That I see that problem with primes as well. Those companies, they're in giant processes and machines. To pull someone out of there to your hiring point might be great people and maybe you could figure it out. But if they've gotten it, indoctrinated into that's the way you do business, it's a tough transition, I can imagine.
Totally. I mean, think about it this way, right? Like if you take a specific program, right? Let's say Inversion is focused on this one program, right? Which is the vehicle, and take an equivalent program at a prime. At a prime, if that program fails for a technical reason or a budgetary reason or something like that, those engineers will get dispersed into other programs. The leaders of that might have their career a little bit, stunted a little bit, but not too big of a deal, and they'll get put onto a different program. If that happens for us, I'm sleeping on a friend's couch for however long they'll let me, right? It is there's a different level of stakes and investment that myself and also our team has in this, right? Where, there is an urgency, like you said, there is no option to lose, because losing means it all goes away. You don't just kind of get to click restart.
Yeah, crazy. So if we look more at the mission, you say you can, talk to me about 1,000 kilometers, you can drop anything within an hour. If you've got your pre-positioned, satellites or vehicles there, if you don't understand aerospace, what's the key operational thing that unlocks? Is really time to resource or?
Yeah. So first, I'll kind of quickly go through exactly how, or roughly how this works, right? We take our vehicles, mainly our ARC vehicle, we load it with cargo on the ground, right? Cargo that a customer knows they're going to want or thinks they're going to want in the future.
Like in volume or, size or?
Yeah, the first variant of ARC will have about 500 pounds of payload. So roughly enough for 3 to 5 people to get usable equipment out of, or useful autonomous systems to get delivered. We're not delivering shipping containers yet, but it's also not like you're getting a single protein bar and saying good luck. And so that gets all loaded, right? It gets launched to space by SpaceX, for example, right? We put our vehicles on there. They then spread out in a network, in a fleet around the globe. And, we need tens of vehicles in space with the same cargo to have global coverage, and much fewer if you care about a specific area. Now they're up there, they're hanging out, they're waiting, whatever. If we now go back down to the ground and think about how this impacts and actual operations, in a lot of ways, it's as if you're just really close to a resupply base. Right. You are operating as if you're in touching distance to a forward operating base, or have an aircraft already in the air that can come and support you. In a lot of ways, it just provides that level of confidence and flexibility, but completely untethered from normal logistics chains. So if you're island hopping, if you are in the middle of the Arctic or Antarctic, if you're, wherever, right, this lets you access the equipment and cargo that you would need to execute a mission or to adapt if there are changing scenarios that you hadn't planned for much easier and much broader than you would have been able to otherwise. That's the kind of core thesis of this, which is you get faster access to the globe.
So they're sitting up there and it says go. What happened? Someone hits their cell phone. I need help now. I need this type of cargo. So your ARC goes, I've got resupply for ammo, weapons, and first aid kit. And so it gets the signal, and then what?
So it gets the signal, and on the flight computer on board the vehicle, it's now planning out its trajectory autonomously on how do I get down to that point of need. It's constantly listening for updates on did that individual move? Did they actually request it to come in from the north rather than coming from the south, so it can adjust its trajectory. It fires its onboard rocket engine. That's needed to kind of kick itself out of orbit, right? It actually falls out of orbit. Once it does that, once it kind of hits the atmosphere, the aerodynamics of the vehicle start to take effect, and it starts to maneuver and glide to where it needs to go. You mentioned the 1,000 kilometers across range. Well, that's super useful because now a single vehicle can glide really far right or left, or downrange or kind of less downrange, to have a large area that it can access to deliver that cargo to. So the ARC vehicle has been called down. It's maneuvering through the atmosphere. It's trending towards where it needs to go, constantly listening for updates. As it gets down to the subsonic regime, below Mach 1, it pulls a guided parachute. So similar to like a skydiver's parachute that you would have, but this one's fully autonomous and actuated with motors and has, sensors that can look down at the ground, understand how far it is, understand what's there. And now ARC is again replanning its trajectory. I know where I need to land. Are there any obstacles that I need to avoid? Did I get any updated information on where the cargo is desired? And it's constantly taking that into account. And then just like any other cargo airdrop, but just happens to be way more precise, it's going to glide in and then softly touch down under canopy where it was requested. That could be, on top of a building. It could be in the middle of the ocean. That could be in a field somewhere. The vehicle doesn't super care. Now the vehicle's on the ground, and now operators can go up and access that cargo very quickly without any specialized tooling.
So from a operator perspective, something that's going quite fast and is very hot. How long does it take so that operators can actually go get equipment out? Is it instantaneous? Like, is it cooled off enough? And
correct. Yeah. So we specifically designed the access panels and payload compartments to be cool enough to access immediately. Because like, what would be the worst thing you could do is like, you have this like life-saving equipment you need, and you're like, you need to let it cool down. Like, that would suck. So we want to be able to go and access and grab the cargo immediately. If you're paying for speed, you don't want to have to wait.
Right. And the parachute, you can be accurate enough. I mean, you can land it on the top of a building. Like, as that proved, so we sent a parade. Did it come back? I think you said it's still up there. Have you proven this re-entry capability?
Yeah, so Ray is still up there. It's going to be doing long duration testing up there. We've already been doing the autonomous landing here on the ground, dropping out of the back of aircraft, kind of simulating that final subsonic portions of flight where we deploy the parachute and the vehicle navigates. And, we're hitting sub 3 meter landing accuracies regularly right now. We still have some variance on edge cases, but we're trying to pull those in to make that pretty consistent. I like to kind of give the example of the most elite skydivers, right? Those guys are able to go and literally land on a target and plant their feet down on a target. So precise that like it is as if you were a drone or something like that. And that is doing it with just 2 eyes, right? Two visual sensors and 2 motors, your arms pulling on the strings on the risers of the parachute. ARC has close to a dozen sensors with 4 actuators for pulling in the parachute and manipulating it. So we believe we can be even more precise than a human.
That's nuts. That is really cool. And so next step is then to get one out there and then do the full cycle. When is that going to happen?
So that's going to happen next year. We're targeting end of next year for the first all-up demonstration of delivery of cargo from space.
Fantastic. What have been the use cases that you can talk to? I'm sure there's some that you can, of customers that is getting the most excitement. Is it more on the life-saving side? Is it more on, it's a munition resupply? Like, where are you finding broad interest or the most interest from your, customer set?
Yeah, well, immediately people recognize the medical and a kind of emergency response side of stuff. It's intuitive. People get that those happen in remote areas and, have either been there themselves or know someone that would have benefited from this, immediately. Especially if we think about a near peer conflict, we're going to be far away from, bases and the ability to go and rescue individuals. So I think there's that is an intuitive, immediate understanding. The next, again, you think, where does urgency and remoteness matter? And that really comes down to the kind of next big category is, what would I have wanted an airdrop for, but I can't get an airdrop for, right? Support in ongoing, like an ongoing battle, right? I think ammo resupply, that kind of like potential thing. And then more broadly, those are kind of like what do you do today that would be beneficial to be able to be accessed from space for people? As you kind of keep thinking about it, you start to realize, well, you can adjust what your behavior is such that there are more and more use cases where people can be in further remote areas. They can carry less stuff with them to those remote areas and know that they can access the gear they need on demand. That's where you start to get pretty exciting use cases.
So the economies of scale and how this works, how do you envision, like, how have you guys tackled that? Because obviously it's not cheap to put something in space and then it may not be used ever. Like, how are your customer sets looking at that? Or it's just part of doing business and war?
Yeah. Well, so it's also not cheap and really expensive to dot that same cargo all around the globe in bases or warehouses. And you need more of it too, right? You need hundreds or thousands of these pieces of cargo replicated all around the globe. And then you may never use it. In fact, the amount of stories I've heard of gear that we've paid for as taxpayers rotting in a non-air conditioned warehouse somewhere is unbelievable. And then it may not even be in the right spot today if you're storing it terrestrially. Like, how many times have we heard stories of like, everything's in INDOPACOM and, we actually need it in CENTCOM or something like that. And so terrestrially, you have the problem of we're paying crazy amounts of money to maintain these warehouses and the aircraft needed to service them and these massive fragile logistics networks terrestrially with hundreds or thousands of replicated units. And yet they're tied to a geographic location. And so if something happens in that area, you quickly deplete that pre-positioned stock. But you can't have so much stock in one location that you can sustain multi-day or multi-week conflict, because it would just be too much stuff to replicate across the whole globe. So that's where the advantage of storing in space comes in, which is you need fewer vehicles or you need fewer units of cargo to cover the same geographic area, much fewer, 2 orders of magnitude. And any piece of that cargo can go to any place, right? A satellite could deliver to, the Pacific, and then 6 hours, 10 hours later could also the same cargo could deliver to, let's say, the Middle East or something like that. And so when you actually start to look at this, you find that it's almost cost comparable today to put these in space and have cargo stored and ready to be accessed, especially for cargo that has high urgency and high need for when it is needed. And that's not even factoring in as costs come down with, Starship as an example, or reusability. It starts to get to the place where you're like, why are we storing all of this cargo everywhere when we can basically have one centralized warehouse, for lack of a better description, in space that could deliver to everywhere? Like, it just conceptually, like operationally is so much simpler than trying to have all of this cargo everywhere.
That makes a lot of sense. And you don't have the atmosphere challenges of storing that cargo.
There's no moisture in space. There's no bugs in space. It is, at least from a storability of cargo, there are less variables, or at least the variables are very well known in space compared to what they are on the ground.
And your ability to dispersion, so you're not under risk of, you take out that one depot.
Yeah, good luck, right? You're going to need to wait 2 days to get something, right? The beauty of this orbiting warehouse is you do not have that single point of failure.
Where do you see this go? Like, where in your mind? I'm thinking like a container box or something like that with 5 vehicles on it that can sort in and shoot, or what are kind of, or are you just like, yeah, that can all happen. Right now we are focused on phase 2.
Yeah. Yeah. So, as a company, we're focused on get ARC to flight, get them distributed, and get those first series of cargo into fleets on orbit. And that's a great way to do this to start, because we're going to kind of go cargo by cargo, right? First, we need to get medical supplies up. Next, we need to get emergency equipment. But once those are all up, call it 10, 15, long term in the future, you can imagine that you would want to have almost like a mini space station that's effectively a warehouse. And it has 1,000 different types of cargo with maybe 10 reentry vehicles, 10 ARCs on the side of it that could pop off and fly down. Now that's a long way off, because that then has a really high cost for that warehouse, that space station. It's lower flexibility because now you have kind of like a single point of failure for various different cargoes. It's less distributed, and it's kind of an exquisite solution rather than a more distributed solution.
It might not even be cheaper, to your point,
Yeah, I mean, I don't actually think it would be, because of how expensive launch is with large volumes, right? You need a full dedicated mission. It gets kind of complicated pretty quickly. What we see is having thousands of these on orbit, such that any cargo or any mission that one might need, regardless of what they're doing or where they are, they can have confidence they can get that cargo in under an hour. That to me is a materially different world than what we live in today. And, we'll start off defense, right? We're focused on defense, but the highway system in the United States was also started as a defense project, right? We need to get tanks from the East Coast to the West Coast. And we've seen what that has been able to kind of allow flourish on the commercial side with, even like Amazon, as an example, could not exist without that. And so I'm excited to see what gets built on top of this 1 hour delivery on the commercial side.
If you were to guess, what is going to be that first commercial need, requirement, or, activity?
I think the first one has something to do with like medical supplies or emergency response, like in a distributed nature. Like you could imagine an insurance company buying like a constellation and having people pay into it. And if they need it, they get it, rescue in remote areas for lost hikers or those kind of things. I think that's the first, but I don't think that's going to be tremendously large. I think that could represent maybe one constellation, one fleet of vehicles on orbit. I think that the big kind of killer commercial application of this is unknown, honestly, at the moment. A good example of this is if you read early interviews and press releases and stuff from SpaceX, Starlink was not mentioned during the, early days. That was not something that people thought of. And it took some time to kind of have that become a reality. I think the same thing's going to happen here.
I mean, I'll tell you what, Justin, this is amazing. I mean, you are truly breaking ground that has not been broken, both from a capability standpoint and then the technology, which we didn't get much into, and I apologize, because I'm sure there's been some production challenges, and it'd be interesting to hear that. Maybe we'll have you, like, when you get your next launch up, let's get back on this. It'll be fun. But
Totally.
I think we're going to have to wrap it up, unfortunately. If folks want to follow, get more information, how best do they do that?
On socials, at Inversion Space is our handle on basically everything. And I just searched Justin Fiaschetti, and I'm the only one, so I'll come up.
All right. You come out to the space conference in the Springs?
Yeah. We've been out the last 3 or 4 years. So
I'll see you at this next one.
Totally, man. That'd be great.
Well, this has been super great. Love what you're doing. I mean, huge capability to our warfighters and just really our country. And so I wish you the best, and thanks for joining me.
Appreciate it. Thanks for having me.